So today we're talking about interval notation. Interval notation basically allows us to talk about numbers which are between values, and we've got a certain notation for that just to help us communicate a bit more easily. So here, for example, we have the set with all the x's in there, and then we have this vertical bar. Let me just zoom in a bit more. I remember when I first saw this notation, I thought, oh my God, university level maths, very confusing. You get used to it, I promise. Basically here, what does that say? Curly brackets on the left and right means that we have a set. So we have numbers in there. Now in here it says all the x's, the numbers, and then we've got this vertical bar. Now this vertical bar in maths, because remember in maths we are very lazy, we don't like writing loads of stuff, so we use symbols instead. This notation here, it means, I'm just making it clear, it means such that. So we have all the x's in there, such that -3 is less than x, which is less than or equal to 2. So they're saying the numbers between -3 and 2, not including -3, but including 2. We know that from the little line underneath. And then in the end, we have this x belongs to the real numbers. So remember here, I'm going to remind you that this means is an element of. So this is an element of. And then here, this R, capital R, means real numbers. So this is an element of the real numbers. I will upload this document with my annotations on Google Classroom later, in case you want to just double check things when you're going back over this and revising. So here they say, this is all the numbers between -3 and 2, but not including -3 and including 2. So if we were to do a representation on the number line, we would basically draw the number line, put the -3 and the 2 there. So these are the two end points. But notice -3 is not included because we don't have a little line underneath. So we just put that hollow circle there. That is because we have, -3 is less than x. So because of that, because -3 is less than x, but then we put a little circle above the 2, which is the other endpoint, and we make that solid. And we make that solid because it says it's less than or equal to 2. So when it's less than or equal to, we make it solid. When it's less than, we make it hollow. But basically, this would be a representation. Now we've got a representation of what they said up there, which perhaps you will find more pleasant to the eye compared with that horrible curly bracket notation up here, which looks a bit scary. So this thing up here is the same thing as this little picture on the right. Let's look at another example. They give us down here x such that -5 is less than x is less than 5. But now here we've got x is an element of. Now this z is the set of whole numbers, of integers. So remember that z, it means integers, which basically means whole numbers. Let's keep this in mind. Let's not forget this notation. So here, how would we represent this bit using a diagram like before? Well, we would say, so here we've got whole numbers because of this z, it means whole numbers. And here we've got the numbers between -5 and 5, but not including the -5, not including the 5, because we are missing a little line under the less than. So it's just less than, not less than or equal to, like we had here. So how do we represent this? Well, this means all the numbers between -5 and 5, all the whole numbers between -5 and 5, but we will not be including the -5 and the 5. So we'll start with -4. So we'll have -4, -3, -2, 1, 0, and then 1, 2, 3, 4. Basically, that's it. We will just put little dots there, because here what happens is we do not want to include the in-between numbers because we just have the whole numbers. So this is just separate dots. You see, the difference between this and the previous one is before we had a straight line, which basically means we will include all of the in-between values. But here, because we only have whole numbers, we will actually keep it as little dots. So this would be a way to represent this visually. Now, let's carry on and do some more examples here. How would you now go backwards and write this using interval notation? Well, using interval notation, which basically means put it in curly brackets and use this inequality kind of notation, you would say, so here we've got the numbers between, let's see, we've got the numbers, I'm going to write it down here, 1, 2, 3, 4, and 5. So how do we say we've got all the numbers between 1 and 5, but they must be whole numbers or they must be natural numbers? Basically, this is how we do it. We say it's all the numbers between 1 and 5, less than or equal to in both cases, because these are both included. And then we say x will be a natural number. I'm going to remind you here that this means natural numbers, which means positive whole numbers. Or we can also use this second notation, which means the numbers between 1 and 5, where the numbers are actually integers, which means whole numbers. So in both cases, it's correct. Obviously, in this case, we have strictly positive numbers, but it's fine. You can still say that they are whole numbers. Positive numbers are whole numbers, so you're fine to use that. So in either the first one or the second notation would be a way to represent this information. So we always open with curly brackets, and then we put x such that, and then we just transform this, rewrite it as an inequality. Let's have a look at a second one. So here, basically, if I were to give you a trick, when you have dots, when we have dots, basically that means that we will be using the natural numbers or the whole numbers, the integers. So one of the two. When you have a line, when you have an interval or line, I'm going to call it either, then you will use the real numbers. So we'll use R for this one. So let's keep that in mind, because here are the real numbers basically means we include everything in between. So how do we start? We say we will open curly brackets and we'll put an x in there, and then this vertical line, which means such that. And then we rewrite this bit as an inequality. So we will say, well, -3 is solid, so we'll have -3, and then we have less than or equal to. Why? Because that is solid. It means we include the -3, so we put a little line underneath. Then we have x, so all the x's which are between -3 and this number here, which is 6. But here for this 6, we'll need just a less than, because we won't be putting the line underneath because this is hollow. We don't want to include the 6. We basically say just about up to 6, but not including 6. So you will include like a tiny, tiny number before the 6, but when you reach 6, no, that's not included. So how do we write that? -3 is less than or equal to x, which is less than 6. Basically means x is here, then you got -3 on the left, and you got 6 on the right. So this is how you would represent this one. Let's just move on now to a couple of other questions here. Firstly, listing the element of a set. Well, which numbers are included in this set? Let's figure out exactly what they're saying. Firstly, they're saying that here we have the integers, whole numbers. So this is integers. We need to remember this by heart. We need to recognize it when we see it. So Z means integers, which also means whole numbers. So it says all of the whole numbers between -2, and notice we've got a little line underneath. So the little line underneath means that -2 is including the -2, and the less than or equal to 1 means that we will be including the 1. So what are the whole numbers between -2 and 1, including -2, including 1? Well, these would be -2, then you got -1, then you got 0, and then you've got 1. So if we were to list these numbers, what would we say? Well, we would say this is just the numbers -2, -1, 0, and 1. So that is pretty much the same as AI. So this set here. So instead of writing this, they could have just written -2, -1, 0, 1. That's it. Let's move on to the next one. Write in interval notation these numbers here. So how would we write in interval notation these numbers here? Well, the first thing we would do is we would do this thing that the textbook has shown us previously. We would say, we would open the curly brackets, and then we would say it's all the x's, so we put an x in there, such So we draw this vertical line. So this is like a formality. We always do this with these sets. We say open curly brackets, put an X there, and then a vertical bar. And then after the vertical bar, you'll say, how do I rewrite this as an inequality? Well, firstly, what sort of numbers do we have? We have -3, -2, -1, etc. These are whole numbers. So the set I want to be using is Z, because that is the symbol for whole numbers, for integers. The second thing I notice is I start with -3 and I go up, but I never stop. I just keep going up forever. So what sort of inequality do I need to have? Well, I need to have -3 on the left, and that will be less than or equal to X. And normally you would have a number that where you stop, and then you would say less than that number or less than or equal to that number. But here it never stops. So basically that would be the way to write it down. But it tends to be a little bit strange if we say -3 less than or equal to X. So often we will just change this the other way around. Not that this is wrong, this is perfectly acceptable. So I'll just put it in a little box to show that that's correct. But usually we would probably just rewrite it as X is greater than or equal to -3. Just because we like starting with X in this case, rather than saying -3 is less than X, we say X is greater than -3. It's just more pleasant. But both of these are correct 100%. So I'll say this is correct, but also the second one is correct, just to avoid confusing anyone if they read this later. Finally, last example, promise. This one is all the x's such that X is between 0 and 4. So I think here, this was a question where we had to list these, and I kind of missed it. It was from the previous part. We have to list the numbers here, list them. So let's come up with a list. Firstly, this N means natural numbers. And natural numbers means that we have positive. So this is positive whole numbers, positive integers. So that's what we have. Positive integers between 0 and 4, but now we will include the 0 and we will not include the 4. So this is including the 0, but not including the 4. So let's see what numbers we actually have. Firstly, we open curly brackets to put all our numbers in there. Now the 0 is included, so 0. What is the next natural number, the next positive whole number? Well, it's 1. And then what's the next one after that? It's 2. Next one after that is 3. And next one after that is 4. But in this case, 4 is not included because it doesn't have a little line under the inequality. So we just list them by saying it's 0, 1, 2, 3, and we are finished. That is pretty much how you would list the numbers.
Can I ask you something?
Yes.
If it's just like 1 on one side, like only if we didn't have the 0 there and only X is it's less than 4, X would be all the numbers below 4.
So if we didn't have the 0 at all?
Yes.
If it were just X is less than 4 with X being part of N, then you would say it's the numbers 0, 1, 2, 3.
Sir, it's because in the question it's 1A, it's saying that X is bigger than 4, and it says to write in a verbal statement. That's the part I didn't understand.
Got it. Okay, so now we've moved on to this exercise, and you're asking a verbal statement. Got it. A verbal statement here. So you would say these are all the numbers greater than 4. So you would do something like this. These are all the numbers greater than 4.
Okay, so and the other one is all the number 5 and the B, so it's all the numbers below 5 including 5.
Yes, so we have a special name for this, and I'll write down the special names. All the numbers less than or equal to 5. Mm-hmm. So let me just write down these notes here. Basically, this we translate as greater than. Then if it has a little line underneath, we say greater than or equal to. So we can communicate more easily. Greater than or equal to. Then if you have the other way around, you would say less than. and then if you have the little line underneath, you just say less than or equal to. So keep this in mind. Maybe write them down somewhere so you can always use them when you're doing something like this. I will be stopping the recording here, and then I'll be talking a little bit more about the interval notation.